All right, so we got problem 4.11. I'm going to solve this using the universal method. So let's get labeling the nodes. So I'm going to call this bottom node ground. Actually, I'm going to do it a little bit different. You could the easier way would be calling that bottom node ground. Actually, no. I'll do it. I'll call it. I'll call the bottom node ground. It just makes it more simple. It makes the answer more straightforward. If I were to make the ground node here, then V2 would be 0 minus, call this V1. That would be your V2. It just, the way this problem is set up is kind of just for you to call this bottom node ground, this node V2, this node V1, and this node 44 volts. Yeah, so we have our current IS. I call this I1, and call this I2, and call this I3. So then go ahead and do our KCL. So we know IS is equal to, oops, let's call this I4. Forgot about that one. IS is equal to I1 plus I4, right? And then we have I4 is equal to, I4 plus I2 is equal to I3. Jeez, this handwriting. Now we do our equation for components. So we say IS is equal to 144 minus V1 over 4. We got I1 equals V1 minus 0 over 10. I4 equals V1 minus V2 over 80. We know I2 is equal to 3 amps. And then for our last equation, I3 is equal to V2 minus 0 over 5 ohms. So our missing variables would be V1, V2, IS, I1, I4, I2, and I3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, then we can go ahead and plug this into Maxima. Yeah, let's do that. Cool. So for Maxima, we know that V1 is going to be 100 volts and V2 is going to be 20. the 1 volts to 20 volts. Right.